You can pass me one of those. You haven't opened yet? Eat lah. Energy over already, right? Pass one. Huh? I didn't see. Okay, I'll take a look at the mango one. I thought this was like the standard flavor. Hmm. Okay, we can start now. The owner of this thing is here. Okay, there we go. Huh? What? Horrendous Don't tell me lah. Okay. I confirm spot a lot of careless mistake one. You're gonna get it from me. Correct or wrong? This one. This one you got correct. You got wrong. Do you know why you got wrong? Okay, so basically, okay, very fast one. This one here, you have to make rho the subject. You got to make rho, then equals to f over 6 pi rv, like that, correct? And then you need to put it in its units. What's the units of force? Newtons. Newtons over, right? 6 pi is a constant, so don't care about its units. R is meters, so put meters. V is a speed, right? They say it's speed, isn't it? Speed, velocity, so meters per second, correct? So basically you got newtons over meter square second minus 1, right? But none of your option is newtons. So you need to break the newtons down further. So newtons, force equals to what? I mean, that's his working lah. So force equals to what? MA, right? So which means that newtons is equals to kg ms minus 2. Do you see that? Then you have to take this and break it down into this one. Okay? But I can tell you that this is kind of like an IB question. This is an IB level question. This thing here, what we have here is really more like okay, I'll tell you this this question here, they modified it. The original question is this: what are the base units of rho? They're asking for base units. You all want to catch up as quickly as you can. Base units. Do you remember chapter 1 got this thing called base units? Do you remember that you have to memorize the 6 base units? kg, meter, second, ampere, Kelvin, mole. Then 7th one don't need to care. Candela. Yeah. Light. Luminosity. Yeah. But that's not none of your business. You only need to remember that 6. So which means that when you're asked to like, you know, express units in base units, you have to express all of them in the original 6 of those, like any of the combination of the 6 units there. That's called base units. But they modified this question because they probably know that you all didn't memorize the base unit, so they just removed it. You go back and go and find out. No, I'm not going to say it here. Okay, quick, next one. Hey, what's this? Right or wrong? For one, I don't know. Like, for one, kg ms minus 2 divided by... So, I mean, yeah, the answer is B lah. Oh, okay. I don't know whether you got it wrong or right until you get it back, but that's the working, okay? All right. Okay. Which of the following sets of errors is correctly depicted? This one, anyone? Anyone need? Don't need, Okay, so, hey, hello. You tick B or you choose C. What's your answer, brother? You cancel B, so B is wrong, is it? Okay lah. I mean, it's true lah. Cool gusts of wind is random, right? Right? It can't be systematic. Okay. Number 3, this one. This one you need me to go through? Don't need, Okay, no need, Kobe, you must stop me also, no, Kobe. Okay. Number 4. Need or don't need? Number 4 need. Okay. Number 4, look at this, So, object in space probe above Earth weighs 3.5. What's this? What's above the Earth? What does it mean? That means in space, not on the surface, is it? Okay, the G field at that height of the space probe is 7. Earth surface is 10. What are the mass and weight? Okay, salah fella. Okay, so you... Okay, what? Hey, these corrections or this is your original working? Hey, hello! You... Gundu Sami Papadam! Your, your, your G is 7. Why are you going to put 3.5? Wait, don't owe me. You got it. You got the equation correct. They literally said the G field strength is 7. Why you going to put 3.5 here? This thing is 7. That thing is 3.5. That's the weight. The weight. W, G, D. Careless mistake. First one. Okay? I will scream at careless mistakes. Knowledge gaps, I won't scream. But careless, somehow you got the equation right. Okay, never mind. So you know that the mass is going to be 0.5, right? And therefore the weight has to be 5, right? So B is your answer here. Damn. Okay, number 4 done. Let's move on next one. Number 5. Number 5. Do you need me to do this? Okay. This one. Always one. This one. Always one. Always one. Always one. This one happened already many times already. Hey, one of you go and tell me what's happening here. Describe this thing happening here. What's happening to it? You know, it is not decelerating. It's decreasing acceleration. Oh. Because you see, I can literally smell the teacher, right? When he said this question, right, he knows already. He knows he's going to be able to trick people on this already. He already, I purposely go and draw the resultant force, and I purposely draw it going down. Then you start thinking, I'll force you into thinking that it's slowing down. It's not slowing down. It's accelerating because resultant force gives you acceleration, but the amount of acceleration is getting less. It's still accelerating all the way to the end, and then it's no more acceleration, means it reached constant speed. So A should be your answer. Oh my days. Can? Somehow you all confidently, you go and answer me deceleration. You all really are. Well, the teacher win this time lah. Okay, whoever said that question, the fellow win this time. Okay. All right. Next one. Stone falls streamly. Air resistance may be ignored. Hello. Yes, it's D. Hello, Mr. Benjamin Tan. Hello, Mr. Benjamin Tan. You need a crash course on acceleration kinematics. Okay? You're obviously your kinematics still a bit not there one. Okay? Constant acceleration, D is your answer. This one. Right? Why your acceleration increase? Right? What? What? That air resistance is ignored lah, bro. What? If there isn't what? If there's air resistance, they are not allowed to ask how the acceleration time graph is because that's not in syllabus. But this one here is this one here. This is the constant acceleration. Okay, if this is a knowledge gap, then you better take note of this. And then when I start revising or when you want to ask me this separately, any of you also same thing, right? Please keep a mental note of this. Keep like tabs on this. Take a post-it pad. Go and take a post-it sticker and post it on it, right? Then for Nathan, if you don't have the paper with you now, you either you take a screenshot of this, right? Store in some folder, then you can ask me later on as well. Okay? But acceleration is constant for this one. Okay, number 7. Alamak, number 7. What's this? Moments anybody? Huh? You got it correct. You got it correct. Who needs this? Yeah, don't need. I move on. Number 8. 8 also correct. So the moments question, because what I did the revision of moments, you can get correct. Walao. Okay, number 9. This one. Wow, hey there. Hey, hello guys. Hey, this word lah. Stores. So they're still on they're on the same page as the O levels. This is the word that the O levels use now. But okay, fine. Hey, but this one a bit tricky lah. So this car is intentionally driving up the hill and gaining speed because they say it accelerates up, right? Accelerates up the hill. Okay, accelerates up the hill. So we say that the kinetic store increased and the potential store also increased. But specifically, what potential store? This one's a bit iffy. What potential store? Gravitational potential store. So you have to say gravitational potential store. Because here's the thing. What happens to its chemical potential store? It decreased, right? So actually not fair, right? The teacher never specify, no? Correct or not? You see? But wait. The answer is what? Is the answer D or C? Answer is D, is it? Actually, you can fight, you know? You can fight. You say potential store, right? You can say that. You see, by logic, right? Gravitational potential and chemical potential store, overall, right? You would lose more chemical potential store than you would have gained gravitational potential store. Because some of the energy is used to create kinetic energy for the car. So technically speaking, C should be the correct answer. Which car is not? Electric car, the battery is chemical potential also. Unless it's a rubber band car. Eh? No lah. You must consider the entire thing. No. Okay, no, Nathan, cannot. If a car accelerates up the hill, the car has a motor. It's not the initial KE that it has. If a car is being pushed up the hill, right? If you roll a car up the hill, if you take a Hot Wheels toy car and you roll it up the hill, it will decelerate. It won't accelerate up the hill. So only cars with motors can do this. Correct. So actually, you can go and fight this with your teacher. You can say that C is the answer because you use the word potential store. You never specify what kind of potential store, right? It could be the total sum of all the potential stores, which means chemical and gravitational potential store. You go and fight your teacher lah. Don't waste time. Basket. Okay. Next one. This one. What's this? Okay. So pulley system. Okay. Pulley system. So how many this is a pulley system? Trying to lift a mass 2 kg up by 3 meters. Okay. All right. So the efficiency of this system is 80%. Wow, Piang, I'm gonna smack you already. This one, I see this working here, I'm gonna smack the fella already. Okay, never mind. Okay. So what is the GPE gain, Benjamin Tan? This one is Lian Ming Tai Sing also. Oi! Don't what me, this is your paper. You tell me what's the GPE. 20 times 30, right? 20 times 3. 20 times 3. Then what how much is it? 60 joules, okay? Now you haven't learned. I think I didn't revise this. Did I revise this? I don't remember. Didn't I revise work energy power? I did, right? Hello. The useful output power of this pulley system is 60 joules. The efficiency of the pulley system is 80%. It means that you need to put in more energy so that this this pulley system can output 60 joules of useful energy. Do you remember what efficiency stands for? Definition of efficiency? Useful. Okay, so I won't use the word power because down here is energy, right? So you can say useful output, right? That means either energy or power divided by total input, right? And the question is asking you for how much total input is there. So how much input do you need to give it? If it's 80% efficient, it means it will waste 20% of it to heat, and then it'll come out 80% is the 60 joules. Don't do that. Walao, I said that time 120%. You see, you see the exact same thing I said, don't go and do that. You literally said to do that. Hey, hello, can you use this equation or not? It's like right here, no, bro. Efficiency is 0.8, right? 0.8 equals to useful output 60 over total input. Can do the math or not? Don't go and do 120%. I say exactly that's how the other tutor go and con my other student. Right? I told you my year 3 just joined me, right? And then tell me that what the tutor go and teach her, oh, 80%, then you add 20% to the 100, then you go and multiply to it. You're doing exactly what the con job is doing. Don't get con. Don't go and con people also. Okay? So total input is 60 divided by 0.8. What? Ah lah, okay lah. The answer is the answer lah. Let's move on. 11 is what? 11 I don't do. I don't want to do this one. This one I have to do my A levels also. I don't want to do this one. This one damn headache. This one. Okay lah. Basically this one here, right? Okay. Yeah lah. Yeah. I know, right? Yeah, it's damn annoying. Like if you take PV divided by P, right? Then the value is just V, right? Okay. I don't want to do this one. I don't know how to do this one. I'll come back to you on this one once I figure it out. Because I know you got it wrong. I also will get it wrong on this one. I will go and put B as answer. Yeah, I know, but I'll go and put B as answer. I still don't understand why is it C. Maybe one day I'll figure it out. But this is the one question that irks me over the years because I have to explain this to my A-level students also. I tell them every time I get this question, I also want to skip. I'll come back to you on this, okay? I won't tell you that something that I know but I don't know one. I'll tell you that if I don't know, I don't know. And 12. What's 12? Do you need me to do this? You get it right or wrong? Okay, move on. 13. 13 careless, 13 you need. Okay, so this one is what? Heated, and it expands at constant pressure. Okay, so number one, do the particles gain Ke? Yes, they do. Okay, the particles gain Ke. So this one is no, right? Gain Ke. But then pressure is constant. Now, do you remember what is pressure factored by? You all give me all wrong answer. Okay, this is molecular level pressure. That means this is pressure explained by molecules. That means, okay, you know what? IP, all four of you, right? I'm going to have to do one ideal gas lesson with you all. Right? Let me try to find a June holiday. Maybe one day I do a crash course, 1 hour. Let me finish up the ideal gas thing with you all because you all are very shaky on this. And you guys are the only ones that need this at this time. Which is super strange because this is an A-level thing. So that means all the other students are supposed to have this also. But the O-level students have been, like this has been taken out of the syllabus. It's damn frustrating. And how are you supposed to go to A-levels like that? Anyway, pressure affected by force of collisions and frequency of collisions. Remember? Pressure is proportional to force. Oh, shoot. This thing is not my okay. Force multiplied by collisions, right? Force and multiplied by frequency of collision. So, okay. Anyway, you write it on your own. My thing here is very messy. Pressure is affected by force of each collision by the molecule. You see the molecule inside here? It's colliding with the piston like that. Smack. Okay? Then multiplied by frequency of collisions. You understand this? Okay. Do the particles gain Ke? They gain Ke, right? Do they smack against the piston with greater force? They do, right? They smack with greater force. However, the pressure is still constant. How can that be? So the force increase, right? But pressure is constant. So how is that possible? The only way for it to be possible is what? The the frequency must decrease, right? The frequency must decrease. But how does the frequency decrease? The piston move backwards. The piston move backwards very, very far, right? The piston moves backwards like all the way to the back here like this. Right? All the way to the back here like that. Sorry. Okay? All the way to the back. So the frequency of collisions will actually drop to a point, right? The frequency will actually get so low that when you multiply with the increased force, the pressure is still maintained. Okay? So we have to see this, huh? B is your answer. Like that. Okay, so here's the thing. I don't doubt what you say, but I know that this is a very this fellow who set this paper threw out all the trick questions. This is question 13, right? But I already noticed at least got 4 or 5 is all the classic trick questions. This fellow is getting on my nerves. Okay. Do I need to do this? Is the answer C there? It's a C, yeah? Okay. Do I need to do this? Oh, why? You wrote this, huh? Alamak. Wow. Should I smack him? I should smack him, right? I should smack him. See this one? Right, 欠打, called 欠打, correct. You're right. This one called 欠打. So you go in the swimming pool, you jump one leg for me, okay? Basket. This one. Hello, Mr. Tan. 200, your work energy power confirm got problem. 200 watts, please write down as 200 joules per second. 200 joules per second for 50 seconds. What's the total energy supply in the 50 seconds? 200 times 50. You go and put 200 there only. Your Q okay, wait. They're gonna make this guy a case study. Do you see this equation here? Yeah. Do you see you wrote only the back half of the equation? Do you realize that you forgot to write Q equals to MLV? Right? Case study lor. Right? You every time I ask you to quote equation, you only quote me the second half. Quote the full thing. Q is in joules, it's not in watts. So it's 200 times 50 equals to MLV. Then you can find your LV like that already, what? Everything given to you in almost SI unit already, you still... Okay, Settle already, Okay, 16. This one. Hey, hello. Like I can understand if you write D, no. But the option C literally says sound, brother. This one not called careless mistake. This one called kiampa mistake. It's really 欠打 mistake, this one. You maybe you write D, right? I still can forgive you, saying that okay lah, you made a mistake. The fella option C, the fella said sound there, ultra sound, no. And someone you go and say, oh, it's a transverse wave. 你做么你 17. Hey, this one not fair lah. Okay lah, fine. Okay, this one here is technical question, right? This one is quite technical. Remember, but actually, do you remember when I was teaching you this? I was saying that the speed of the wave depends on what? Speed of wave depend on medium, correct or not? The water wave depend on depth of water. The string wave depend on tension of string, correct or not? This one is sound wave depends on air, liquid, or solid, right? Then speed travels fastest in solid, travels slowest in air, correct? But then they change the air. They make the air temperature higher. So this one is on me, because if I had just given you a little bit more detail during that lesson, then you will realize that when air temperature rises, right, the air expands, so the particles are further apart. So if the particles are further apart, what will happen to the speed of sound? Correct. Slower, because sound requires the collision of the particles to transfer the sound energy, correct? Transfer the vibrations or transfer the kinetic energy of the particles. If they're no, but they're still spaced very far apart. That's the problem, right? The gaining in, you're right, gaining in KE doesn't compensate for the fact that particles are further apart. Yeah. So it becomes less dense. So sound, right? Sound travels fastest in denser medium. Correct. So if sound becomes less, if air becomes less dense, then sound will travel slower. So D is answer. The answer is C, meh? Hey, this one you go and fight. You go and fight your teacher. You go and fight your teacher. Temperature increase, less density. This one, that means okay. Ben, was it Kobe? Ben, is it? You telling me that the answer is C, is it? Answer C, ah. Okay, can. That means you go and fight your teacher on this. He got this one. He got this question correct. We got to choose C. But down here. Okay lah, don't fight lah. Walao eh, you are. Okay, so by my logic, right, if air temperature increase, right, the density of air should be less, so the particles are more spread out, speed of sound should be lower. Okay, but that means this question is not fair, because how are we supposed to know the effect of like the gain in ke of the particles versus the spacing of the particles? That's not fair at all. All right? Yeah, that's true. No, you're right. You're right. So Nathan is saying that what happens if this air is enclosed in a box, then it can't spread out so much. Then the particles just gain Ke without spreading out, right? Then yeah, right, Nathan. Then the particles would have more Ke and can transfer sound faster. But they never say, right? Nobody said, right? Nobody said that travel through air trapped in a box or anything like that, right? So void the question. Tell the teacher. Wow, Sienna, but you all got it right, leh. Okay, never mind. Then you all just keep quiet. Only Nathan can go and fight with the teacher because he hasn't gotten his paper back yet. Okay. Uh this one don't need to go through like microwave sterilization, UV. Okay, can this one also done, right? This one also don't need. This one here. This one need or not? This one? Hello, brothers. Okay. What's the current angle of reflection now? The angle of incidence 60. The angle of reflection will also be 60. Then they want what? Rotated clockwise. Rotated clockwise. So if you rotate it clockwise, then the new mirror is like that lah, right? Not like that, right? By 10 degrees, right? By 10 degrees. So then this angle here will be 40 degrees. Then but then the normal will be also shifted, right? By 10 degrees, right? Then the new angle of incidence will be 50 only. So then the answer will be 50. Oh. C should be the answer. Okay? Wow, this fella really pulling out all I mean, he's pulling out all the tricks in the bag. Yeah, Literally, you know, all these questions are all your classic trick questions. Eh. Oh man. He never touch what? He never touch what? He never touch the paper. The first 6 question. Oh, open-ended question, sorry. Oh man, okay. Oh, did he get it from Nanchao Secondary again? This one new or this one? Huh? This one new ah? Yeah, like this one you didn't memorize this one. This one you go onto the Fed website right? You go and play with the thing, right? You move the object nearer to focal point, you'll see what happens to the image. You're supposed to memorize this. But anyway, the answer is that the image become larger like this. Yeah. But actually you could have drawn it out, right, brother? Yeah, that's why lah. This fella non-committal one and some more don't go and put it at F lah. That's why you got it wrong, right? You put it nearer to F, then you just draw the thing lah, right? Like this, then like that, then you let it cut like this. That's me lah. Fella never commit. The fella never commit. The fella only do halfway. You like swimming in the middle of the pool, then you just stop, is it? This one? This one. So this one is magnifying glass. To the left, magnified virtual B is your answer. Don't tell me you never memorize this. Don't dare to say. Next one. This one memorize one. You got it. This one, 23. What happens to the electrons? Alamak, the balloon. Wait, against your hair. Okay, wait when a balloon is rubbed against your hair and becomes negatively charged. Okay lah, the balloon becomes negatively charged lah, right? Nothing wrong with the language, right? Next one. 24. Okay, C. Good. Next one. Both negative, right? It cannot be right, brother. I just thought this like how many weeks ago only. This one is only a few weeks ago only, you know. Hey, Mr. Tan. I just thought this a few weeks ago only. Why you gonna put A? You're gonna see the lines going in. That's a negative charge. Like you had 2 options, right? You had 2 options. You had like either this one or this one, right? Why didn't you read the rest of the choices? You see the first one only. Hey, same one. Then you just put A, is it? Yes. This one? Is it a whole stack? I think it's a whole stack, bro. Oh no. Oh yeah, it is. Yeah. This one? Which of the following does the resistance of the conductor depend on? This one, D are all above. Okay, can. Next one. What is true about the resistance of the filament bulb? It increases as the... Okay, can. 27. Okay, done. 28. True for ohmic conductor. Hey, answer. Wait, who said A? Who's... The answer is A? The answer... Wait. No. Ohmic should not increase in temperature. That's what makes it ohmic. So A shouldn't be the answer. But that would be a non-ohmic resistor. No, like C's answer. What do you, wait, hang on, Ben. Why are you telling me that A is answer? You mean the teacher marked A as answer for this one? See lah. It's ohmic, right? Ohmic means 29. Who got? Huh? This one you need. Why? Okay, wait Okay. Firstly, these two lamps, right? Will it affect this one? No, we mentioned this before, right? Okay. So you go and shine light on R. Shine light on R, right? Okay, you shine light on R. What happens to the resistance? Light increase, right? Then the resistance decrease. Then the voltage decrease, right? So then the voltage of this one will increase what? Potential divider. This side here, the voltage decrease. This side here, the voltage will increase. So L2 will become brighter. But L1, nothing happens. L1, nothing happens. Because L1 is a parallel branch from these two. But C what? C is the answer what? Right? Why? Hey, okay, I don't want to be a Nazi, but seriously, right? You really have to learn how to put a cross instead of a tick because your brain will start thinking that, just cross it out. Hey, you all, Okay. Walao, some more redraw diagram, some more, no. So look at this fella. Guys, the ammeter has zero resistance. I don't see you tracing the current. The current flows here and bypasses the 3 ohm, doesn't bother with the 3 ohms, and then splits into the 2 and 4. So the 3 ohm is not part of the resistance. That means you only got a 6-volt battery, right, with a 2 ohm and a 4 ohm resistor in parallel. There is no 3 ohms. Never trace current, that's why you got this wrong. Okay? Can I move on Okay, question 1. Question. Wow, Piang eh. What the pong is this? What do you make mistake on? You forgot to draw the T. Walao, draw and label all the forces. Why you never draw the T? Sorry, Kobe, what? They say draw and label all. You just follow instruction. Anyway, your diagram sucks. What the pong is this? That means you need a crash course on vector diagram. Correct or not? Huh? No, don't have. Frictionless. No. Okay. Hey, hello. Okay, you drop me a message for my lesson on vector diagrams. I just did this with Sonia. Okay, you understand? You make sure you drop me a message for vector diagrams. I'm not going to go through this because to go through this it will take very long. So you go and watch the thing first. You go and understand why we draw vector diagrams, how to draw vector diagrams, and what are the steps of drawing vector diagrams. Okay, because otherwise it will take another half an hour to go through this one. This one is confirmed you can watch in the video one. Right, so make sure you message me. What is this? Wow, this whoever this is, this fellow really. Oh, you're saying that this one is the teacher lah, right? His first 6 questions, is it? Okay. He's really pulling out all the common trick questions. That's what he's doing. Yeah. Okay. Wait. No, you want to learn how to do this, right? You learn how to visualize this thing first. You see, there's a planet here. Then there's a rocket that's about to land on this planet. So this rocket is free falling at first. But then you cannot let the rocket land on the ground like that. Pop, the rocket will break into pieces. So what must the rocket do? The rocket must use its booster to boost itself, right? After falling for a certain point, right? Then it needs to fire its engines, right? Fire its engines like do the thing, right? But he's doing it in such a way that the upwards force, right? The upwards force is going to cause him to slow down. So before he starts boosting, he's falling because of the gravity. Do you see that? This first part here, Mr. Tan. Mr. Tan, just focus. All right, got 20 more minutes only. Okay, so this rocket at the start is falling because of the planet's gravity. Do you see that? Gravitational pull. Okay, as it falls to a certain point, the rocket will then turn on its engines to try to slow it down. It needs to decelerate. This rocket doesn't have a parachute. Understand? So by giving itself some boost, all right, then it will be able to slow down. So the thing is this, okay? The rocket falls down towards the planet because there is weight. You see the small green arrow here? That's the weight. Doesn't matter. So the weight is whatever the weight is, this is the weight. But because it has fallen, it has gained some speed. So can I get you to understand that this is like the first section here? This is number one. This is number one here. Do you see that? Okay. So the moment he turns on his booster, his rocket engines, he's gonna start boosting upwards. He will have a greater force upwards than his weight. Do you see that? Where's the resultant force in this picture where my finger is? Where's the resultant force? Hey. The resultant force is upwards. Okay. So the resultant force for this picture here is upwards. F net is upwards. But where's the velocity pointing? The velocity is pointing downwards. Do you understand? Where's the acceleration pointing? Upwards. Upwards. The acceleration is pointing upwards. Okay. So at the very moment his rocket boosters turn on, he is exerting a resultant force upwards because his rocket booster's force upwards is more than the weight, so that he can get acceleration upwards. But his velocity is still pointing downwards. Okay? Right? Because he gained all the velocity pointing downwards. Like, well, this question is really like a lot of layers. So this one here, right? He enters the planet, right? He enters the planet and then he free falls. So he starts off at 10. This is 10. And then he reaches a speed of 82. Do you see that? Okay. Then with the rocket booster pointing up, he will start to decelerate. He will decelerate all the way until it reaches 0 and he lands on the surface of the planet here like this. Right? Okay. You want to land with a almost 0 speed. The V is almost equals to 0 like this. Right? 28 seconds. Right? So this is like stage 2. Right? Stage 2 here like this. Okay? This is stage 2. So all the way down, this is stage 2. Clear? Yeah. Okay, good. So this is what happens for this is what happens here. So they ask you calculate the weight of rocket X on planet Y. Wow. Wow, this guy is but this guy is this guy is annoying lah. So you have to W equals to mg. Whew. Okay, fine. G is what? For Earth is what? 10. 10 what? What's the units? 10 Newton per kg, right? Every kg mass, you will get 10 newtons, right? But it's also the same as 10 meters per second squared. Okay? So if you can find the gravitational acceleration of a planet, that's the gravitational field strength of that planet. G acceleration equals to G field strength. I think, Ben, like from the past few questions, I've noticed that's what you've been making mistake on. Like this thing is very shaky for you. But this thing is what? This thing is March of last year. So depending on where you were March of last year, I don't know, maybe you were swimming or whatever it is. This probably the reason why you keep making mistakes for this kind of questions. Like you keep getting it right from the previous parts as well. Okay? Right. So W equals to mg. M is that mass there. That's the mass. This is M. G, you need to find the gradient, right? Like what Nathan was saying, you need to find the gradient of this graph because that's the gravitational acceleration due to the gravity of the planet. Right? Do you understand this? Right. The gradient is the G here. Do you get this correct? Okay, yeah. Okay. Hey, Ben, are you taking this down? Hello, Ben. Don't get distracted. I only got a few more minutes left. You want to do whatever you want to do, you do it later. You please take down all these things I'm saying here. All right, I'm moving on now. Okay. This one here, precarious, because I wouldn't have, like, I mean, it's 1 mark, it's not so bad. But do you understand that during its descent, the thrust force upwards is more than the weight? So if let's say I had drawn a box like this, you have to show the thrust like that, and you have to show the weight like this. If you show me different size forces, right, or equal forces, you would have gotten it wrong. And I suspect you might have thought that it's the same size. Okay. Do you understand that the thrust must be more than the weight? It cannot be equal. If it's equal, then the rocket will be at equilibrium. The speed wouldn't have slowed down. The speed would have remained constant if the force was equal. But because, right, they tell us that the speed is decreasing, means that the thrust force is actually more than the weight of the rocket. So that the resultant force is pointing upwards. So that the acceleration is pointing upwards. So this will cause the rocket to decelerate. All right. Now I'm going through this very quickly. If you still don't know what's going on here, please drop me a message and then you ask me to explain to you another day, right? Same thing for everyone else. I'm just using his paper as an example. Okay. This one, tough, right? Tough, don't care. Don't go and waste time on this kind of question. If you realize that this thing is a bit of a waste time kind of question, right? Then just move on. Really, legit, guys, you need to learn time management because when Ben sent me the paper this afternoon, in 2 minutes, I scrolled all the way to the back of this paper, right? The last two questions is doable. You would have lost a lot of time trying to figure this one out, but you could have used that time to go and do those questions at the back. Learn your time management. Tough question. What kind of funky question is this? Don't care. Just like whatever lah. Just move on to the next one. Do what you can. Right? If you can't do this, that's fine. Then just move on to the next one. I don't know what's the answer for this one. Seriously, I have no idea. Do I need to care? Do I need to care about this? Nathan, you cannot tell me you cannot convert 70 cm cube to meter cube. You cannot tell me that. You cannot tell me that. Let me teach you the quick conversion. 70 divided by 100 cube. Okay? Okay. Can. Pressure exerted by the right ventricle. What's that? Oh, it says right ventricle pumps at the lower pressure approximately 1/5. So this is divided by 5 lah. Okay, then what's the next one? Work done. Okay, this is unfair. Wow, this one's unfair. Oh, this is unfair. This is unfair. This question here is not fair. Like who is trying to be special here again? Fuller is just being special lah. Seriously. He's just trying to be special all the way, right? Okay, this one here is work done is equals to PV. Okay, right? Do you learn this? This is IB. This is IB thing. This is IB thing. Okay, you're supposed to find the change in pressure multiplied by the volume of blood that you pumped. That's the work done. Oh no. It's just no. Sorry, work done by right ventricle. So work done by right ventricle is just P times V. But who would have known it's P times V? Forget it. These two questions, these 4 marks here, swa, never mind. I will show you the proper working later. But this one, you really don't have to waste time on this because this is not even in your syllabus. Since when do you learn this? Work done is equal to P times V. No lah, go and derive this. Okay. Work done is force times distance, right? Force is pressure times area, force, pressure equals to force over area. So force is equals to pressure times area times D. Area times D is volume. Ta-da! Damn extra lah, cannot lah. You cannot ask students go and derive this kind of equation, especially when they never did this before lah. But anyway, this 4 marks, right? Swat, never mind, just let it go, man. Yeah. Okay, come, let's go on to the next one. Can I go on to the next one? I'll show you the proper working for this. This one here is you need to find the difference in the pressure between the right and left ventricle. Bio students over there don't do this. Okay, number 4. What's this? The next time I see anyone write for physics, molecules colliding with each other, I will refer you to your chemistry teacher and tell your chemistry teacher that this only belongs to chemistry, not for physics. Particles colliding with each other has nothing to do with us. What are you trying to do? Calculate effective collisions. Hello? Mr. Tan? Yeah. I don't even know why he gave you a tick. Collide with the walls. Air particles don't even vibrate. Collide with the walls. Collide with the mercury surface. Exerts a force, exerts a pressure. I wouldn't even give you 1 mark for this, bro. Okay, next one. Exerts a force, exerts a pressure. You have to have both. Okay, you have to say that the air particles in the trap region moves at high speeds, collides with the walls and the surface of the air of the mercury, right? Exerts a force and hence exerts a pressure. You're supposed to say that. Ken, this answer would not have been acceptable. I don't know why he gave you 1 mark even. But here's the thing, guys. Is whatever I said an extra thing? Is it extra? Is it like the PV thing? No, right? I said it before, right? Okay? I said it before, it's in my notes. For pressure, no, for actually kinetic particle theory, sorry. Okay, so now I know your teachers like to play with kinetic particle theory. Okay lah, only this. Yes, wow, you're listening. Okay, yes. Hey, anyway, I got the ACS temperature and this one, I got this one ideal gas notes also. So look at this. Huh? Temperature and ideal gas, look at that. I have this one. But actually in my own notes also I have it. Right? I kind of like just told you all to just if your O levels will ignore this because apparently this is no longer in syllabus. This one there? This one. Right? Particles are in continuous random motion. They move at high speeds. They collide with the walls. They exert a force. The force, right, divided by area is the pressure. Okay? Okay, fine. I have to go through this with you all. Because I didn't emphasize this when I was teaching kinetic particle theory. Because for most of them, right, they don't need this anymore already. Okay? It was taken out of syllabus for them. But obviously, this is in syllabus for you still. Okay? Alright, this is on me. Okay. Hang on, Okay. Mr. Tan. There's only one of you here, Mr. Tan. What does this mean? Okay, can you read this thing? What does MM stand for? What does HG stand for? Oh, mercury. Yeah, correct. You got mercury. Then how do you get it wrong? Okay, do you not know how to do this one? So you don't know how to do this, right? Okay, as in like you don't understand the barometer totally even. No lah, if you don't tell me you understand a bit. You don't understand means you don't understand one. Because this whole thing will require another half hour or something like that one. You understand? Okay. So I'll tell you this. Please make a note that you are kosong about pressure. Okay? Because this kind of question, right, is you either you get it or you don't. You don't get it, there's no way to get half credit one. Right? You get it completely wrong. You understand? So you need to learn the whole thing from scratch. Did you learn this with me, Mr. Tan? Did I go through this in a revision? I didn't, right? Pressure. Okay. So that means you kosong on this, right? So you take a note of this, but I want you to take note of this. For all of you, I am going to do pressure and work energy power for my year 3s on Saturdays. So you either you ask me for its recording or you join in the lesson on Zoom. Okay? So obviously pressure is a problem. Okay, so either you attend the lesson or you ask me for the recordings. Can I leave that to you? Like you can you like be responsible for reminding me to send you pressure stuff? Okay, okay, then I'll move on. I won't. Uh. So so basically, you have to find out what's the height of the mercury column here, which is 73, right? Which is 73. Then they say that it's 14 mm above. Wait, it's 73 cm. It's 73 cm. Then they say that the pressure down here is pressing down 14 mm, right? Okay. So they're asking you what's the true atmospheric pressure. So the true atmospheric pressure is the 14 mm plus the 73 cm. Which is, plus. Yes, that's right. So mmHg is mm of mercury. Don't forget this Hg is mercury. A lot of common mistakes is students think that this Hg stands for height and g, which is wrong, right? It's just the mmHg. But in any case, I think the video will be more important, right? The basics is more important. Okay? Can. Let me know when you get your paper back. This one, I'll try my best. This one, hey, hey, why didn't you get 1 mark for this one? No, but why didn't you get 1 mark for this one? Hello, Mr. Tan, why didn't you get 1 mark for this one? You calculated the heat loss by the water, right? You calculated the heat loss by the ice cube tray, right? You added them both, right? Okay, firstly, why the world do you divide by 2? Did they ask you for average? They ask you for average rate of thermal energy. Rate of thermal energy. So technically speaking, you should have gotten 1 mark for these 2 Qs, but you're supposed to divide it by time. What do you think rate means? Divide by 20 times 60 seconds. All physics must be in based on SI units, bruh. So sorry, what? Cannot also. Unless, 2640. Yeah, correct. So unless you do this, unless you go in 20, right, then you say joules per minute. Hey, not fair lah. Who see? Oh, that one ah. That one no choice, that one. That one no bopian, right? He anyhow make rule one, right? You should calculate the average power. Power of okay, doesn't matter lah. Rate it means by seconds so time 20 times 60 seconds okay. Right. So anyway, he play us, then no choice lah. Okay, Ken. Are we okay on this? This one settle Why? Oh, guys, you see, right? When you bring the 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 water and the ice cube to freezing point, means to 0 degrees, right? Has the water frozen yet? Not yet. What do you need to do? You need to, yeah, I know you need to change its state, but what do you need to remove? Latent heat. So you need to remove Q equals to ml, right? So you need to go and find out how much heat do you need to remove from the water. You don't need to remove any more from the tray because the tray is at 0 degrees Celsius. You remove this latent heat from water, it's going to stay at 0 degrees Celsius, right? So this is the additional heat to be removed. Okay, wait, additional heat to be removed. So how much water is there? 200 grams, is it? So, gosh, 0.2 times latent heat of fusion is 330 kilo. So 330000. Okay, you write this down, you at least you get 1 mark. But this is not fair. This is not fair because this one depends on the answer from before. That means you need to have this rate here. You need to have this rate here in order to calculate how much additional time is needed. At least 1 mark cannot. Yeah. Why? It must be what completely correct, then can get full marks. Where got this kind of thing one? What? This one in minutes, this one in minutes, and he marked not even 1 mark. This fella is damn niao leh. Wow, this fella is damn niao, you know, this fella. No, he gave you 1 mark out of 4. Give 2 lah, 1 lah. ECF also, right? Your method here is correct. ECF, you should be getting 2 here, what? This fella, not only, okay. Okay, this is a good question. This one is a good question, okay? Right. Why the time required for the water in the ice cube tray to freeze completely from its initial temperature of 31 degrees Celsius is longer than the time calculated in part B? Okay, so the thing is this. Okay, what is the temperature of your freezer, guys? Your freezer, guys, come tell me what's the temperature of your freezer. What? -20, -10, that's good, okay? It's basically not 0 degrees Celsius. You understand that? Right? It's -20 degrees Celsius, for example, okay? Usually fridges are more like 20 now. Okay, so the thing is when you put water in, when you put the water in at first, right? Okay, you put the water in at first, the water is 31 degrees Celsius, 31 degrees Celsius. You see that? Okay? So as the water cools down, it loses heat to the surroundings. The surroundings is -20. The thing is this, as it cools down further to 0, the temperature difference between the surroundings and the water is getting smaller. So the rate of heat loss will get lesser, which means that it will take actually a longer time to freeze. You understand what I'm saying? That's the answer. That's the 1 mark. Do you catch that? I say it again. So at the start, the temperature difference between the surroundings and the water is, temperature difference is what? Is larger. So the rate of heat loss of the water is larger. Okay, the rate of heat loss is larger, right? But as the water cools down to 0, the temperature difference becomes smaller. So the rate of heat loss becomes smaller. So the time taken for the water to freeze will take longer than what we calculated in part B. Sorry, one more time, Ben? Yes, that's correct. You? Hello, the ice is trying to freeze. It's trying to lose heat. What you say there is heat gain. It's heat loss to surroundings. gain heat from where? The surroundings is minus 20 degrees Celsius. No lah, no. I think he just saw your thing and then he didn't realize. You better change the word to heat loss. Yeah, heat loss the surrounding. You better change that to heat loss the surroundings. Not heat gain. There's no heat gain here. Sorry, what? Ben, what? Yeah lah. Okay. So yeah, this is just wrong. It's basically the okay. This question here is a good question because rate of heat loss is proportional to temperature difference. Go. Okay. Right. So this one here. Okay. Next one. These waves. Bye bye. Benjamin Tan. Hello. Okay. The wave travel from there to there. You go and take one whole wavelength and then you go and divide it by t. The t 0.125 is only the time taken to travel from here to here. This is not the full wavelength distance. Like how far did he travel here like this? Is it this 0.75? So the speed is equals to 0.75 divided by 0.125. You understand? Okay. I tell you what this guy is doing, okay? This guy is really pulling out all the common common trick questions. Okay, he's pulling out all of it. Like everything that he's doing here is all common trick questions one. Like means that all your questions are all trick questions, right? The fella is just trying to trick you. Okay. Do you understand this equation? V is equals to lambda over capital T. Why capital T? Why lambda? Why capital T? Lambda is one wavelength. Good. Capital T is one period. One wavelength divided by one period. Okay? The problem is I don't know how long does it take to travel one wavelength. They only gave me this time 0.125 is the time taken to travel this small distance. This small distance is only 0.75. What this guy is trying to do is speed is equals to distance over time. That's it. Right? So he's trying to trick you guys. What? Then the question that you get, the answer you get from here is also is basically related all these three. This one is here is you really waste the 3 marks here. You got ECF for this question. What mistake do you make? Hey, wait hang on Hey, wait. Yeah, it travels 0.75 in the 0.125 second. You see, they said that the dotted line shows the displacement at t equals to 0.125. Then you should have known that it only moved by a bit, not one whole full wavelength. By the way, I see your equation, right? The equation is wrong. Do you realize that I emphasize so much that your capital letters must be correct? You go and write small f equals to 1 over small t. This equation is definitely wrong. This one is 真的是你欠打. This one is really you can't part this one. Small f equals to 1 over capital T. Right? Capital T stands for what, Benjamin Tan? Yeah. Frequency is 1 over period. Since when is frequency just simply equals to 1 over small t? No such thing. You understand? Okay. Draw the displacement time graph of particle P from 0 to 1 second. Where's particle P? Particle P is here. It's at the amplitude. When you're at the positive amplitude, right, Mr. Tan, when you're at the top, where do you go next? Yeah, you go down. So you can draw the displacement time graph. Wait, this is not even their axis. This is your own axis. You draw the axis and you give up halfway. Okay? I don't know what 1 second is because I don't know what's a period here. You have to go and calculate the whole thing. Please go and do your corrections. Are you able to do corrections on your own? Go and do the corrections. I don't care whatever the teacher, like, don't tell me that teacher is going through tomorrow or the day after. You go and do your own corrections now. Or maybe during class tomorrow or something. This one is you cannot have gotten it wrong one. You get it wrong is really very wasted. Okay. This one and this one I think still not so bad. This one and this one is still not so bad. Uh who go and mark you wrong for this one? But anyway, this one was okay. This one was okay. This one was okay. So this one here, the static electricity is still not so bad. This one, hello sir. I went through this, right? What happened here? I think this was one of the exact questions I went through in class somewhere, you know. What happened? I'm almost done already. Question 8 and 9, I'm almost done already. I will let go of you all of this torment after this. What? You what? Oh my 天. Okay, so you know what this means? This means that you lack of time here already. You're rushing already. Is that right? Fair or not? Huh? You're rushing already, right? Huh? This part here, question 8, question 9, you're rushing like mad already. Are you able to do corrections on your own for this? Can I'm gonna assume that you know how to do this because I went through this with you. Like when you joined the time, right? This was what I was doing. So cannot be you lose marks, because of this thing here, right? Time management, I understand, but you cannot not know how to do this. So please go and fix it. Uh, okay. This one is really you. Okay, Ben, you tell me. Hey, Benjamin, you tell me. You tell me how to answer this part C here. Like, what's the concept at part C? No, no, no. As in, can you tell me, like, I have a phrase for this. Like, I have a concept phrase for this. No, no, because I don't see it in your working also. It seems like you completely didn't use whatever I was teaching you. I don't see it in the working. That's why I'm asking you. Potential at a point, right? No, no, no. Potential at a point, not potential divider. I told you I was teaching this, right? Okay. Do you need me to send you the video for potential at a point? Yeah, the understanding of how to get CD is basically drawing out. Okay, this potential here is 12. This one here is 12. Then this one here is 6. Then this one here is 0. I didn't see you do the markings here. That's why I knew you didn't and use that method because they're asking you for the PD between C to D. It's basically asking you to put a voltmeter between C to D. Yeah. Why do you get 0 volts for D? Huh? Oh, okay, okay. Okay, fine. Okay, fine. Then that means what? You made a careless mistake or what? Okay, you go and fix this. You go and fully understand this. Is it supposed? Why is this wrong? Okay. Question 9, this one. Okay. Did I not go through this? I did. I did. Using which equation? What? What? Kobe? One more time? No. No. Okay. Wait. This one is no choice really. Because I've gone through this, but then yet I'm getting. Okay, wait. No. You'll stay online until I find the video for you. Where are you getting that from? Where do you go to find that? Yes, it is. I'm just finding you the video, guys. Right, this one here. I'm just gonna send it to you all. Cause you're not allowed to not know how to do this. Wow, my basket. I go through this one, but maybe I don't know lah. It was in January. Okay, never mind. I'll explain that. But maybe because it was January, maybe you all still new, don't know my style yet, right? I give you all chance, but after today cannot, no more chance really. You all cannot make this kind of mistake. You all wait I wait Okay. Really sometimes not worth rushing through things one. Seriously, I remember now that. Okay, anyway. So Kobe, come. Kobe, let's finish up this one. Okay, this is optical fiber. I sent you the video, but don't go and watch it now. Kobe, are you there? Okay. Okay. This is optical fiber. Where is the light? Where is the light signal traveling? Yeah, traveling through the core. Okay. So the light is doing this. What is the light doing? Correct. It's doing TRR. So what they meant by core cladding interface is this part here, right? So I zoom into that part. Can? So this is the core and this is the cladding. Okay? How is the light ray traveling? Yeah, sure. It's the core is the core, right, in the middle. Okay? So the light ray is traveling from the core, trying to go to the cladding. But instead of going into the cladding, it does this. Right? It does TIR, correct? Okay, but why does the light ray do that? Why does this light ray do this thing here? Like, what are the conditions required for it? This angle of incidence must be larger than the core cladding critical angle. Okay? Now the video I just sent you, I noticed the date. It's like in January. It was like I think when you all just started out or something. I don't know. Because I remember you came, like, I think Kobe, you came for like one lesson during the holidays, and after that I didn't see you for a damn long time. Then suddenly you came back. And I think that was like probably this was like the first few lessons I had with you. I don't even know whether you attended it or not. Did you? Okay, but maybe you didn't realize my style at the time lah. Okay, but this angle here is bigger than the core cladding critical angle. So you have to go and find the core cladding critical angle. Okay? Is that what the question is asking for here? Yeah. So they want you to find the critical angle of the core cladding interface. So here's the thing. If you're asked to find core cladding critical angle, that means you have to remember what's the definition of critical angle. Definition of critical angle is the light ray is traveling from denser to less dense. It hits the surface, and then it's supposed to have an angle of refraction of 90 degrees. When that happens, this is your critical angle of the core cladding boundary. Okay? Okay. This, okay, I'll tell you this, this is on me. All right? I really regret skipping this one because I remember vividly now that I was thinking maybe I should teach you all how to find the critical angle of core cladding. But maybe I did. But I remember I mentioned this to one of the classes earlier this year. I don't know whether it was you guys or some other class, right? Maybe the year 6 or year 5. Year 6, yeah. I really cannot remember. But I remember going through this for one of the classes. I don't know whether it was you guys or not. But this is how you find the core cladding boundary. Now to understand this, right? Okay, so firstly, does anybody have doubts understanding this? Kobe, you understand this part? So to find the critical angle of the core cladding, we follow the rules of critical angle. Angle of refraction is 90. Okay. So then we use n1 sine theta 1 equals to n2 sine theta 2. What? Yes, correct. So doesn't matter 1 or 2 is the core of the cladding. Okay. You just choose one. So if let's say 1 is the core, then we say 1.5 sine C is equals to 1.4 sine 90 degrees. Then you find C. That will be your answer. Ah, so I got go through before. Okay, I'll go and find the video again later. Okay, but yes, I think I remember going through this before with you guys. You do the math lah. That's not my job lah. My job is to tell you that this is the way to find critical angle of a non-air boundary. But I went through this before. Okay. Okay, fine. Right. I think maybe it's been a while. Right. It's been very long. Right, since January. So I don't blame you for that. Okay. But there you go. So because okay, whoever said this paper is damn nasty. Yeah. So if you have the critical angle, then you go and find the refractive index. Oh, sorry, speed of light inside the core of the optical fiber is just based on the refractive index of the core, 1.5. So it's just 3 times 10 to the power of 8 divided by 1.5. Okay? Part B is a non-related question to part A. Part B is just finding the speed of light inside the optical fiber in the core. So it's just 1.5. 3 divided by 1.5. It's just the ratio of speeds, right? But because you lack of time, you probably left it blank already. Huh? Oh yeah, I haven't explained C yet. I haven't explained C yet. Seven minutes. I'll finish this. I'll explain this in 7 minutes. You all give me your 7 minutes. This question is super technical. That's not the last one. That's not the last one. Okay, wait. Let me see this one first. Faster. Okay. Um, More difficult to hack. Uh, yeah, that's true also. That's true also. And you can, but okay. So basically, the true answer is that it can be transferred at a higher bandwidth. The answer should be higher bandwidth. Did I not say that before? Okay. Yeah, bandwidth, bandwidth. The keyword is bandwidth. You can transfer more data at a shorter amount of time. Okay. But this one here, wow, this one, why do they give 3 marks for this one? Okay, so anyway, this one is wrong. You now know that the critical angle is not calculated like this, right? Okay, so you have to do the Snell's law again for this one, right? Find the critical angle. A bit nasty lah, whoever said this question, because you're supposed to use this equation here and then use it again here, right? Like that's not very nice. Okay, hang on. You want me to do this? I'll do this with you guys. Can you find the critical angle with me for this one first? Hurry up. What's the answer for this? Louder a bit. 69.0 degrees, is it? Nice. Okay, then if you change it to this one, if you change the values to this one, what's the critical angle for this one? Sorry, what? Okay, 54.6, 54. What? 64.6, 64.6. Okay, hang on. 64.6 degrees. You guys ready? I explain this one first, then I go back to part C. Okay, part C is very technical, so I'll show it to you first later. Okay, but basically this is it. Okay, this one here, the critical angle is larger, right? No, smaller, right? This one here is what? This one here is 69, okay? And the other one is 64.6, okay? So which one has a higher likelihood of TIR? Which one? This one. This one will create a higher likelihood of TIR. Okay? Right? Because it's a smaller critical angle, so you will get more chances of TIR. You understand? Right? Because that one is so big, right? The critical angle for the first one here is 69 degrees, right? It's much bigger. I mean, it's 5 degrees bigger, about 5 degrees bigger. So the chance of, like, means that your light rays, right? If it's smaller than 69, it will be lost into the cladding. Right? But if it's less than, but if the critical angle is smaller, so let's say you're 65 degrees or 66 degrees or 67 degrees, now you will no longer be lost to the cladding, correct? Guys, you understand or not? Can All right. So which means that you will get a stronger signal at the end of this optical fiber. Okay? That's the answer. Correct. So more light rays is able to reach the end of the optical fiber, and therefore you get a stronger signal at the end of the optical fiber. Okay, let me just draw it out for you, okay? All right. This was the original one. This is the original one. The critical angle of this one was 69 degrees, correct? Okay. This is the new one. The new one, the critical angle is 64.6 degrees, right? The critical angle is 64.6 degrees. Now, if let's say you had a light ray, if you have light rays that attack at 67 degrees, what will happen to this? What will happen to this one? This light ray will refract into the cladding. It will refract into the cladding, and then the signal is lost. Right? The data is lost here already. But if let's say you have the same one here, right, and let's say it's 67 degrees, which is more than the critical angle, this light ray will TIR, right? Then you don't lose the signal. So you will get a stronger signal at the end of this optical fiber. Because you basically, anything that goes from 65, 66, 67, 68, all these light rays will be transmitted to the end because they can all do TIR. So you will get a stronger signal at the end. Understand? That's the answer. Okay, Ben? Okay, good. So back to this one. This one, okay. Listen very closely because this one here is very technical. So I'm going to finish up today's session with this. Okay. This is the core, right? This is the core. You have a light ray you have a light ray that's going here like this. Okay. Now, what was the critical angle calculated again? What's that? 69, Okay. So I need you to understand. What if it's 69.00000001? It will TIR, right? So some teachers, they don't say it, but I'm going to tell you this. So if the critical angle is 69, we just take 69 as the total internal reflection angle. Yes, it is. But imagine that it's 69.00000001 degrees. Will it TIR? Yeah, we are just taking it as a 69 as the TIR angle, like the minimum angle to TIR. You understand this? Okay. So basically, you have a light ray that goes like this, and it continues to go like that, all the way to the end. Do you understand that? Okay, All right, good. Listen very closely, okay? There's a flaw in this question. The question should have said, determine the maximum time taken for the signal to travel through the fiber. The maximum time taken for the signal to travel through the fiber is when it bounces up and down. Do you understand this? Because it travels the longest distance. Oh, correct. So it would travel up and down all the way. What is the least amount of time taken to travel through? What would have been the type of light ray? If you, yeah, correct. If you get a light ray that travels straight through like this, that would have taken the least amount of time. So this question here is a bit silly because this question didn't specify, do you want the minimum time or do you want the maximum time? So that's why I say that this question is flawed. They forgot to put determine the maximum time for the signal to travel through the fiber. Okay? So I'm going to assume that that's what they want, the maximum time. Because if you want me to calculate the minimum time for what, just what? 2 km? But I'll do both for you, okay? All right. They want minimum time. Then cock, right? They never say, right? Not you, lah. I'm saying the marks team, lah. Okay, anyway. So, okay, but what if they want maximum time? What if end of year exam, they ask you for maximum time? How? Wait, I show you how. Wait, I show you how. Okay, hang on. Let me just put it onto my. Okay, hang on, guys. Let me just finish this up with this. Okay. Can Okay. So if let's say I want maximum time, Maximum time is this, guys. Listen very closely. The cable is 5 km long, right? You see this, How much? Oh, 2 km long. Sorry. Yeah, thank you. 2 km long, right? See this, You take all the ups, you put it all to one side. Okay? All the up, 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 up. You lay all of them side by side like that. And then you put all the downs and you lay them all to one side like this. Down, 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 down. Right? You lay them all like this. Okay? What is the total distance traveled by the light ray? If it had to travel, right, the maximum distance covered by the light ray. That's right. That's right. You would have to do something extra special. Okay? No, but here's the thing. Yes, I know it's troublesome. All right. Okay. You know, yeah lah. But you can. I guess you can do some trigo shit lah. Right? You can halve it. You can 1 km one side, and then trigo find one side and then times two. Don't need to use sine rule. Correct. Yeah. Okay, but this will be the if you want maximum. So if let's say you want maximum, then you have to take 2 times of the hypotenuse, right? 2 times. Okay, so maximum will be 2 times hypotenuse distance. Okay, but that's not the point. The point is this: the time taken will be dependent on part B, the speed of light in this glass. What is the speed of light in the glass? Correct. Speed of light in glass, right, is equals to 3 times 10 to the power of 8 divided by 1.5, which is 2 times 10 to the power of 8. So you have to use this speed of light in the glass together with, if you want maximum distance, if you want maximum time, you use the maximum distance. If you don't want, then you use a minimum distance of 2 kilometers. Right? Nathan is correct. Okay? So this is in case something extra comes out end of this year, this thing here, because I've seen this happen for the MGS paper before. The MGS IP has come out with this question before. All right, I'm done. You guys okay? Okay, I gotta go home. What? Sorry. Yeah lah, yeah lah. Time. Okay. Yeah. You can find the time based on whatever distance you wanna. 50 meters. How many seconds? Okay, so speed equals the distance over the time. Time is equals the distance over speed. Yes, he's right. Okay, but you have to use this speed, right? Because it's traveling in the glass. So the distance is either the maximum distance, this plus this, or the minimum distance, this one. 2,000, brother. 2,000. Oh, 2,000 meters. That's right. Okay, make it a habit. One more time. I think you also a bit shaky on this. All physics equations use SI units. You got to remember what are the proper SI units for every quantity. Okay? Hey, guys, I'm here at 10 o'clock. Right? I'm quite tired. I need to go back home. I'll see you guys in the next lesson. Okay? Okay, bye, guys. Hey, yes. Oh, thanks, Nathan. Bye. Yep. Alamak. I will take a look at it on my way home. I see. Okay, bye. Yeah, Kobe. Ice Cube. Why? Oh, no lah. I think your teacher is a bit nasty on. Very hard to fight on. But okay, just take in comfort that you understand how to do it. That's the most important thing. Just remember to convert it to SI units for the final exams. Okay? What that? Wavelength question, no? Why? Oh yeah, it was very rushed. I can imagine that this paper is a bit rushed. Yeah. Okay, anyway, I gotta go. See you guys. Bye bye. Bye bye bye.